Hi, welcome you all on Physics Addhyan. So in the previous few lectures, we have seen or we have discussed about the general line, surface and volume elements in general curvilinear coordinate system. And we have discussed about the Cartesian coordinate system. Now the important topic is to discuss spherical and cylindrical coordinate systems. So because they are mostly used in physics, everywhere you will get them. You will mostly you encounter them in your electricity, magnetism, and everywhere in mathematics, in Cartesian, in your quantum mechanics, in your while you will be solving your integration polar coordinates, you will have to encounter about the spherical coordinate systems. So let's get to the basic transformation and let's try to uh, get a feel of spherical coordinate systems. So so first let me define okay. So this is my Cartesian coordinate system. This is an XYZ. So if there is a point, let's say there is a point P from, let me use another color. So if there is an position, let's say a vector that is a position at point P in the plane. So there is a point in plane whose coordinates can be given by XYZ. Okay, this coordinates P uh, can be given by X, Y, Z. So in Cartesian, you will write R vector as X I cap plus Y j cap plus Z k cap. If I wish to denote these coordinate systems by another set of coordinates, I will specify how I will deal with. Let's call it as r, theta and phi. I will define right now what is r, theta and phi. Then r vector you can write it as a r r cap plus a theta theta cap plus a phi phi cap. So first we will write the transformation equation, then we will find the scaling factors, and then we will do the general calculation. So let me define what that r, theta and phi is. So the vector OP, the mod of OP is your r. In this, what I'm using at r is mod of OP. So that is the position of that point O, which you are dealing in spherical polar coordinate system. That is the origin to that point distance. That is OP is your uh, r. Now, what is theta? Theta is angle between OP vector and Z axis. So this is the angle theta. And let me write it here. What your r is, that is distance of point P from the origin. What your phi is, that is the angle made by projection of OP on XY plane, that is angle to X axis. So first what we will do, so this is our XY plane. Okay, I will take a projection of this OP vector on this XY plane. Let this fall is here. So I will call as another vector in XY plane. Let's call this as Q. Then the angle made between O and Q, this is your phi. So the phi basically is your angle between, that is angle between your OQ and x-axis. So these are the coordinates which I am using here, r, theta and phi. These are called spherical polar coordinates. These are called spherical polar coordinates. Now, if I wish to find the transformation, and we will see this if you want, by changing the r, theta, and phi, you will complete a sphere. That is why these are called the spherical coordinate system, and we will see in just a few seconds. So, let me define this distance as r. This distance is theta. So, its projection on z axis. So, this is basically the projection on z axis. Sorry, this is the perpendicular to z-axis, so this is the projection of this OP vector on z-axis. So if you calculate it, so it will be r of cos theta. So if OP has a projection in this O, let's call it as OQM call, so OM is equal to nothing but r cos theta. This your PM will be similarly r of sine theta. This PM is same as OQ because the both are projections. So if I take this projection on this XY plane, so this is, you can shifted XY plane, you can call it r sine theta. So this will be your r sine theta. So if OQ is your r sine theta, then this OQ also has two projections. So it has two projections, one is this and one is this. So your this length will be r sine theta and this angle is phi, so this is cosine phi. This is your r sine theta into sine phi. So this is basically your z, this is basically your x, this is basically your y. So one can write your the transformation equations that are the most important. R is equal to r sine theta cos phi, y is equal to r sine theta sine phi, and z is your basically r cos theta. So these are the transformation. In the first video I have shown you that there exists a unique transformation. So from Cartesian to spherical polar coordinate system, whenever you go from Cartesian to polar, replace xyz by these coordinates. So this is the most important and widely you will use. So these are called transformation equation. Transformation equation. Okay, so the first thing. Now the thing is came, what are the limits? How does these changes? So if I say, let me move further, and because I have to use the above figure. So this is your x, this is your y, this is your z. So if I call this as r, so this will be r direction. If I change the increment in r, so it will be like this direction. So this is r, this is increment in r. This direction is your theta direction. So theta goes from 0 to somewhere, let's call it as limit, and this is your phi. Phi basically, so phi basically moves in this direction, in this direction. So you have one thing that, so let me because this is a thing of visualization, so let me state something and you visualize that. Suppose you have a line, a single line, a pen or something. So suppose you have a line. Let me do it in this coordinate system so that you can have a picture of how the limits of r, theta and phi came from. So take phi is equal to constant. So first take phi is equal to constant. Let's call it this phi. First take a theta is equal to constant and phi is equal to constant. You will have a line because two surfaces are constant. So you will have a line. So in general, constant. So in general, I will have a, let me do this. If you fix a particular theta and phi, then you have a line in this xy coordinate system. So this is your O, this is your P position, and this is a line. Now theta is not a constant, then theta can vary from here to somewhere. So if this is your line element and you want to vary it by fixing this O fix, so it will be basically an arc or if you increment it, so it phi is still a constant. So if I change from position A, that OA was a line, and I change it to OB, so it will cover some surface AB. If I further improve it, it will become a 1/4 of a circle. If we change it by pi by 2, so it will be cover a disk. Okay. Now if phi is not constant, so now this disk will rotate. So this was the initial position, and then this angle is fixed. Now this will become this. At some other instant of time it will rotate and make like this, and at some further angle it will rotate and make like this, and further it will complete. So this rotation is going like this way, so it will complete a phi cycle. So first you have a line where theta is constant and your phi is constant. Okay, your these two coordinates are constant. Then you have a line. Now move theta is not equal to constant and phi is still a constant. So this line will transform to some time of disk. If you go maximum to pi by 2, then it will transform a disk. Now if you theta is not constant and your phi is not constant, then this disk will transform to sphere. So think in a way that there was a line and you rotate it in a theta direction, keeping your phi constant. So it will make a disk from that line, because when you move a line it traces a circular path. So considering that area, you will get a you will get a disk, and then rotate that disk about that axis, okay, in phi direction, so it will complete a sphere. So that was a visualizing part. Hope you will get it. If not get, please do a comment. I will try to answer. So that was the first thing. Now the limit comes. R has no limits. That is the second important question. Limits. So this was our coordinate system, x, y, z. This was your p, this was your r, this was your theta, and this was your phi direction. So r has a limit 0 to infinity because it starts from 0 and goes to infinity. Phi has a limit 0 to 2 pi. This is all I talking about sphere. Okay. And theta has a limit that is 0 to pi by 2, because if you want to complete a sphere you have to first make a half circle. So for half circle you have to rotate this line from here to here, and then rotate the disk from first you have to make the line this disk, half disk, then you have to rotate it like this in phi direction. So this was your r direction, this is your phi, sorry, yeah, theta, and this is your phi rotation. So then it will complete the sphere. So this is for a sphere. So if you want to choose a half sphere or hemisphere, then what the limits will be? So for hemisphere, so see, if you want to complete the hemisphere in the same coordinate system, so let me erase it and make a newer one. So now you want to make a hemisphere. So first choose your r. Okay. Now corresponding theta. So if you vary your theta from here to here, it will complete a 1/4 of the circle. Now you move your theta along this xy plane. So move in this direction. You're changing theta. So this is your theta direction and this is your phi direction. So if you transform it, then you will see that you will get the hemisphere. So for hemisphere, r is equal to 0 to infinity. The theta limit change from, sorry, that will not be pi by 2. This will be pi. Pardon for mistake. Because initially your limit was to complete a sphere, you goes theta from here to here. So that is 0 to pi. And for hemisphere, that is 0 to pi by 2. And for phi, it is 0 to 2 pi. So for hemisphere, your theta limit changes from 0 to pi by 2 because this is your xy plane. So this is your xy plane. So you have to come from this point A to this point B. So you have to rotate theta by pi by 2 angle. So I'm really very sorry for this mistake. Hope you will see the video till last and you will correct it. So limit for theta will be 0 to pi. So now I wish to write the general h1, h2, h3, du1, du2 and all this thing in this spherical coordinate system. So we have this transformation equation. R is equal to R sine theta cos phi. So this is your R sine theta cos phi. Y is equal R sine theta sine phi. Your Z is equal to R cos theta. So if I wish to write dx, so your dx will be basically differential of these three. So it will be let's differentiate. Let us start with R. So this is sine theta cos phi dr plus then again differentiation, let's have an theta. So this is R cos theta cos phi d theta, differentiate again cos phi. This is minus of R sine theta sine phi and d phi. Similarly you can write for dy and dz. So this will come out dy is equal to, I am writing it fast, sine theta sine phi dr plus r cos theta sine phi d theta plus r sine theta cos phi d phi, and this is similar minus r sine theta d theta plus cos theta dr. Now you find ds vector, that is your dr vector dot dr vector. So this is dx I cap plus dy j cap plus dz k cap dot with dx I cap plus dy j cap plus dz k cap. So when you do this, you will get all, you do the squares, you will get dx square plus dy square plus dz square. Now if you do this, sorry, you will not get this. If you do this calculation, so no, you will get that dx square plus dy square plus dz square. Now if you put dx, dy and dz is equal to this, you will get dr square. You will add these two, all will be equal to 1 plus r square d theta square plus r square sine square theta d phi square. Remember that ds term which we used earlier, our ds was h1 square du1 square plus h2 square du2 square plus h3 square du3 square. Okay, so from here you can calculate for a spherical coordinate system, h1 is equal to 1, h2 is equal to r, h3 is equal to r sine theta, and in general you will write u1 as r, u2 as theta, u3 as phi, and your e1 as r cap, your e2 as theta cap, your e3 as phi cap. So these were the terminologies which we'll use. Uh, these were the parameters that we calculated. Now I'm going to write some vectors, and this thing I have probably done in my matrices transformation lecture. from going one coordinate to another coordinate or changing the transformation. So you can have an idea from there and you will calculate your r cap, that turns out to be sine theta cos phi I cap plus sine theta sine phi j cap plus cos theta k cap. Your theta cap will be cos theta cos phi I cap plus cos theta sine phi j cap, and this will be your minus sine theta k cap. Your phi cap will be minus sine phi I cap plus cos phi j cap. And in the next upcoming lecture I will show you how this r theta phi came to be, r cap theta cap and phi came to be this. I will show any one. uh, okay, let me show you one here. So what I was trying to, okay, let me find r cap. So find r cap. So we have three transformation equations. We have x is equal to r sine theta sine phi, sorry, sine theta cos phi, sine theta cos phi, cos phi. Y is equal to r sine theta sine phi, and your z is equal to r of cos theta. Let's find this quantity, x square plus y square plus z square. So this will be r square sine square theta cos square phi plus r square sine square theta sine square phi plus r square cos square theta. So here these terms will combine and this cos theta square plus sine phi square will give you 1. So this is r sine square theta plus r square cos square theta. This will combine, this will give you r square. So your r square is equal to x square plus y square plus z square. Okay. Now if I wish to find, so I have concluded this thing. Now if I wish to find the r vector, so this is xi cap plus yj cap plus z k cap. So your r vector is r sine theta, r sine theta cos phi I cap plus r sine theta sine phi j cap plus r cos theta k cap. So this is your r vector. If r cap, so this is r vector by modulus of r vector. So this is your, and basically modulus of r vector is your under root of s square plus y square plus z square. So this is nothing but r. So if you divide this by r, you will get sine theta cos phi I cap plus sine theta sine phi j cap plus your cos theta k cap. So this was the first thing, how you calculate your r cap direction, and the second rest theta cap and phi cap are for you for your homework. Or we will, uh, if you are not able to do that, please comment in the box. I will try to uh, give you a hint or how to calculate it there. Okay, so that was about the spherical polar coordinate system. The next thing in the next upcoming video, this will be the same for the spherical polar coordinate system. We will define length, area and the volume element of this coordinate system. So thank you for this. Have a nice day.